I chose to ask this question, why a class on RF design? Even though, as I said, I do expect that you have heard the words RF and the word design before. And I broke this slide into two main areas in the sense that the area on the left-hand side probably represents things that you're already familiar with and things that have been running for many, many years. For example, I do expect that most of you have played with some type of a wireless game console. I do expect that most of you have interacted with a computer, and I do expect that most of you have at least attempted to establish a wireless router at home or at work. So you already know that wireless connectivity is actually key, and in fact, it's very hard to live today's life without being wirelessly connected. And if you doubt me on that, try it for a month, and let's see what happens. However, there are many other applications that are coming very rapidly, that are coming into our near future. Many of them are already here. The general public actually even knows about them. For example, I have chosen one here called the Internet of Things as one of the areas where wireless design is actually key. So what do we mean by the Internet of Things? We mean this idea of connecting devices together such that in a network they can actually make decisions. So for example, we talk about smart homes, right? But if a home is supposed to be smart, and let's say turn the heater off when you leave the house and turn the heater on half an hour or an hour before you get to the house, the home needs to know where you are, right? That means that that home has to have a wireless connectivity with your phone that probably tracks you through a GPS signal. And already we have covered now 3 wireless connections in just one simple example. Of course, there is a wealth of other applications, including, for example, smart ways of taking care of your health, including organization, including shipping, and so on and so forth. But the key behind Internet of Things is that you actually take advantage of the networking principles and the networking value that comes from connecting devices. Areas like these are actually multi-billion-dollar markets that people are exploiting very, very fast, and it's extremely likely that those things will impact our future as well. However, that RF design for most of these areas is actually hidden from the public. It has become so mature and so advanced that we actually take it for granted. Most people believe that things should simply be connected, and they don't exactly know why. It just works, right? It's almost like getting an apple from an apple tree. It just happens. And in the future, it will happen more and more. So the other thing that I wanted to mention about RF design, why a class on RF design today, is that, as I mentioned, RF design has been with us for a very, very long time, but it's changing very rapidly. So when I took my first RF design course about 20 years ago, I definitely learned the fundamentals. But in terms of how to think and how to exercise critical thinking for answering problems, things have changed dramatically. I'm going to be actually emphasizing a lot of these things in this class. This class is not about equations. It's actually about thinking. And you will see as we go through this process how many times we actually have to think in a vertical scale, as I like to call it, which means from the device perspective all the way to the systems perspective. And in fact, the second class is dedicated on systems, and the last course is dedicated on devices. And so you will see how basically when you need to make a decision, you have to consider all of them at the same time. Let me give you just one example of how things have changed dramatically and are changing dramatically, so you get an idea of what I mean. For the previous generations of wireless communications on cell phones, the generations that you might have heard as 2G, 3G, and today as 4G, we basically work on what we like to call a broadcast model, which means that there is a tower here. That tower is often called the cell phone tower, and this tower actually broadcasts the signal everywhere, right? So it doesn't matter if you are, for example, at 90 degrees from the tower or 0 degrees from the tower or 60 degrees from the tower, you're actually going to get your signal. And if you leave the area of that cell phone and you go to a different area, then fine, you're going to get a signal from a different tower, but angle doesn't matter. Now this is actually changing a lot in 5G. In 5G, we're actually going to go away from this paradigm, which has been with us for generations of RF engineers, How long, you might ask? Since Marconi. Since 1901, we have been thinking that way. So literally right now, we're changing our design where basically we're going to be shifting to a point-to-point communication for 5G. So 5G will be different. 5G will literally be a cell phone tower or whichever name it gets, and it will literally direct the signal directly to your phone and to no one else. So there's going to be point-to-point communication because of the frequencies we're choosing and because of the data rates that we have to achieve. 5G, we're talking about a millisecond delay and over 10 gigabps per second of speeds, which have been unprecedented. So to deliver this type of service, we actually have to change our mind about RF design. So that's why if you actually just pick up a book today and you try to read, even this book, which is relatively recent, and you try to read about how do I do RF design, and then you talk to a working professional in RF industry, you're going to be out of phase by a few years. And this design is changing rapidly. I'm going to mention more details, and we're going to learn a lot more about these things as we go along. But I just wanted to give you just one striking difference about how everything changes just because we're trying to deliver service at an unprecedented level compared to what we've done before. My favorite slide, why a class on RF design? Because this thing is hard. Why is it hard? It's not hard because we make it hard on purpose. We don't like to torture people, at least not on an everyday basis. But it is hard because it's an inherently multidisciplinary area. It takes actually many topics to get at least a reasonable level of understanding to be able to address the complex questions that we have to address. For example, somebody has to understand the basics of electromagnetics. I mean, at the end of the day, we're talking about waves. So unless you understand at least the fundamentals of waves and how those things interact with devices, it's very hard to make anything meaningful. At the same time, you need to understand something about communication theory. At the end of the day, electromagnetic waves by themselves don't communicate information. There are some bits that are traveling on them, and those bits have some information encoded in them. You need to make sure that your design actually lives within some type of a power consumption budget. It's not very nice to have to charge a cell phone every 5 minutes. Also, you can come up with the best possible device, the best possible design, and tell customers, you know what, your new cell phone from now on is going to cost you 40 grand. Unlikely you're going to succeed, right? So I'm not going to go through all of these areas that I'm listing on these slides, but I do want you to be alert because the easiest thing in the world is to basically pick one of these and just optimize your design on one of these. And honestly, this happens way too often. Even in the research community, you will find too many papers out there which they will say, here's a design that satisfies, it has the lowest possible loss. Well, great, but is it manufacturable? Is there any technology I can use to make it at a reasonable cost? What about its power consumption? And does it deliver more than 1 bit per hour? So my point is, it's easy to get an optimal design on paper in homework, but it's not easy to get an optimal design in the real world. So keep this chart in mind because I will be actually poking you and encouraging you to think about these things as we make new approaches and new choices in this class.